so Marla needs to find the height of the building. The height of a building. From a given point on the ground, she finds that the angle of elevation from the top to the top of the building is 74.2 degrees. Okay, so if I'm going to draw a picture, we have some building. We are trying to find the height of the building. That's our unknown. If I say angle of elevation, elevation and depression, we start at a horizontal line. This is from the ground, so I have a horizontal line on the ground. So from there going up would be my elevation, because elevation is up, depression is down. So that to the top of the building is 74.2 degrees. She then walks back 35 feet. So she was here. Now she is going to step further away from our building. And look at a new angle. And from, this distance is 35. From here to here. From the second point, the angle of elevation is 51.8 degrees. Find the height of the building. Alright, so we can assume that a building makes a right angle with the ground. How many right triangles do we have? Two. Now, unfortunately, I don't have enough information in either triangle. If I'm going to be able to solve it, I need at least one side. The first triangle, if I want to call this y for a second, I have my opposite and adjacent. So what trig function involves opposite and adjacent? We could say the tangent of 74.2 degrees equals x over y. We're trying to find x, so if we multiply y over, but we're kind of stuck. That doesn't help us finish it. If we look at the whole triangle, okay, this is 51.8, so if I set up my tangent from there, my opposite side is x. What's the adjacent side of that big triangle? Remember, we did a couple problems like this at the end of the last section. You didn't have any on your homework, but we did some like it as class examples. Alright, so even if I take my two separate triangles and set up my trig functions, I'm not able to actually solve it all the way. But that actually is not a problem, because what could we do now? These things are both equal to y, then they have to be equal to one another. So we can say y tangent 74.2 equals y plus 35 tangent 51.8 degrees. And we do have to distribute. Y tangent 51.8 plus 35 tangent 51.8 degrees. Now what?
Subtract over the y tangent 51.8.
Unfortunately, these aren't like terms, but what we can do is take out the y. So now we have y times something, so we can divide it. Be a little cautious when you plug these in. Every time you push tangent, it opens a parentheses, so you have to close all those. You also need an extra set of parentheses around that entire denominator because it has more than one term. So I get my y to be 19.6527. Did you guys get that? So
Can I borrow one of your calculators?
where are you at?
I'm in Coach Kirby's.
Yeah, just can you bring it back?
Yeah, I'll
up?
get it to you at the beginning of next hour.
Okay,
Thank you.
you're welcome. So once we have y, we were trying to find the height of the building. That was x. Once we have our y, how do we get x?
Take 274.2.
You could even go back and just plug it back in right here. Either one of them technically, but this one is faster. We already said x is y, which we just got to be 19.6527. Tangent is 74.2 degrees. So I get 69.45. How many significant digits were given in the problem? Yeah, some of these were 3. 35 is just 2. So if there's two different numbers, we go with the smaller. So we'll have to round this to 2 significant digits. So we would say 69 feet if I said to round the significant digits. Questions there? Take a second and see if you can draw a picture and label our information. have an isosceles triangle, which means two equal sides. And we know both of those are 24 centimeters. Each of the two angles measures 52 degrees. So the two equal angles would be our base angles. Okay, the base is the bottom. Where's the altitude? The height, so it would be, we drop this perpendicular. So if I want to find that, we really have to consider half of this triangle so that we have a right triangle. So we can find either one of these first. If I call A my altitude, I want to find that. What trig function would we use? So we can say the sine 52 degrees full pi over 24. Pi over 24. And that gives us 18.9123, or if we round it to significant digits, it would just be 19 centimeters. If I want my base, what would we have to do? So if I found this side over here, I call that x. I could say cosine of 52 degrees equals adjacent over hypotenuse. That's 14.7759. But is that the entire base? No. The base goes all the way across. So what would I have to do to get the entire base? So if I take that times 2, it gives me 29.55. So we would have to round that to 30 centimeters. So my altitude, or my height, was 19 centimeters. The base was 30 centimeters. Any questions there? Let's do one more. So I have lots of examples on here. We may come back and do some more at the end of the hour if we need to. Let's go to the very last one here. I didn't do this one yesterday, did I? It's another bearing one. So we have a boat. Travels on a course bearing north 37 degrees 10 minutes west for 79.5 miles. So if we're going to measure bearing, we have to have a starting point. And what do we have to draw at our starting point? And so from there, I'm going to go northwest. My angle is 37. How many miles north and how many miles west has the boat traveled? So we form a triangle. I think the easiest one is to take this straight across. This would be my miles north. My miles west, so we just have to do 2 trig functions in order to get it. So from here, if I wanted my north, that's adjacent, 79.5 is hypotenuse, so we can say the cosine. 3710 equals north over 79.5. So multiply that over. How many significant digits did we have? 3, so we would call this 63.4 miles north. And to find our west, we could do a similar thing. From here, west is opposite from hypotenuse, so I could say the sine 3710 equals W over 79.5. So that would be 48